All right, good afternoon, everybody. This is the next lesson here for the quadratics unit. We're looking at transformations of quadratics. So we're going to look at the idea of the basic shape, which we've already talked about, but I'll remind you of it. And then the idea of transforming it to have different shapes and locations. Transforming it to have different shapes and locations. In case you couldn't hear me over our bell in the day here. All right, so the basic shape transformations, by the way, you're making it different shapes, like taller, skinnier, wider, whatever, right? That's stretches and compressions. And then the shifts or translations, they're called, you're moving left or right or up or down, right? So when you've graphed quadratics, they've been sort of in various locations, right? So we'll see how they sort of end up there. So here we go. The main idea, of course, is you want to think of the basic quadratic shape as this one here, right? The familiar quadratic, and also the idea of the step pattern that's known, right? That basic quadratic shape of having an over one and up one, and then an over another one, you go up 3, and then over another one, you go up 5. I can't quite show it here, but the 1, 3, 5 pattern needs to be sort of something you're very comfortable with. And also think of the idea that you could graph this 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4 graph and draw it. That shouldn't be a hard thing eventually, right? Where you're just graphing that thing super easily, knowing the shape, and there's no calculations needed at that point. You just have the basic shape understood and known. So the next step is to be able to transform it and make all the different versions of things, right? So I just want you to focus on, I'll use the mouse pointer here. I just want to focus on this, the graph itself here. So I'll move the picture there. So you can see that blue graph and just focus on that blue graph, and we'll look at, being able to make that thing be, taller and skinnier and wider. I even went upside down by accident, not even meaning to. We can move it left and right. We can move it up and down. That's the idea of what we're going to understand the math of. Of course, we could probably learn a lot about the math by paying more attention and looking at that applet, but I want to go about it a slightly different way. You certainly could use that link, though, to do this as well. So what I'm looking at doing, what I normally do in class, is I'll have students try to guess my graph. Okay, so if you use GeoGebra or Desmos, if you're more comfortable, or any graphing program really that works, that you're able to use, doesn't matter to me at all. We go to how to get out of this. Sec here. Alt tab maybe. I want to go to there we go. So if I go to Google, I just type in GeoGebra. I said this in a previous video. It's like my computer knows me well, but type in GeoGebra and it's going to pull up that graphing calculator. I don't need the changes here. And so, the regular quadratic, you do your x hat 2, right? The x power of 2 thing. And so it's giving you a regular quadratic, right? So on my lesson, got the regular quadratic, just like you see, and then it stretches to be this taller, skinnier one. So pause the video, try and, oh, by the way, down here, the equation, of course, is that basic y equals x squared. And you can tell it has that classic 1, 3, 5 shape. So I may as well put that on here just for emphasis, right? Over 1, up 1, and then over 1, up 3, and then over 1, up 1, 2, 3, 4, 5. Dip on this one, right? So all that important stuff to know. But again, you could graph y equals x squared, or you should be able to graph y equals x squared very quickly and efficiently. You got your 0, 0 spot. One sec here. I need the pointer tool or line tool here. That one. So, you graph your 0, 0, 1, 1, your 2, 4, and even your 3, 9. Like, you're just squaring the numbers, right? So minus 1 squared is 1. Minus 2 squared is 4. Minus 3 squared is 9. Graph the line, so that's your starting point for your graphs. You start by graphing that. And then you're going to transform it to be this new shape. So we're going to end up with this taller, skinnier one that's, something along the lines of, I think it's about like this if I were to do a rough drawing of it. I missed a little bit on the left side, I can tell, but we'll get to that in a second. Okay, so that's decent how it is though, right? So we're think of it as you're grabbing this thing and stretching it upwards. And so I should extend this, like that, basically to show we're grabbing these and stretching it way up and making it eventually be that shape. Okay, so that's what I want you to think of as having happened here. So in GeoGebra or similar graphing program, play around with it. Press pause in the video, type in different values, see if you can figure out what it is. Okay. If you've tried, if you're pressing play now and you come back and you're not sure, I'll give a hint. And then you can press pause again and try again. But the hint would be to notice some of the key points that are on the graph. So in this one here, you can notice the point -1, 5 and 1, 5, right? And more detailed hint here would be like, we were here, right? We were at 1 and 1. And so what happened to make it become a 5? Okay, so something happened which, turned, let's say a 1, right? A height of 1. Let's say a height of 1. Losing my drawing tool because I'm using the one where I use my finger. So this 1 becomes a 5 by some process, of course, right? And also though, all of the numbers would have that same process. So a 0, notice a 0 stays the same. And we had a 3, right? Well, where does the 3 end up? We had a 3, was it a 3? Sorry. The original one, a 4, right? We had a 4 right here. And so that 4, where does it end up? If you decided what this process was, the 4 should end up at the right spot as well. And you can tell it's way off the grid, somewhere way up there. Right? So for example, if you thought maybe you're adding 4, that wouldn't work because if you added 4, we'd have 1 right here and we don't. So it's not add 4. Right? So really the only other option in arithmetic would be to multiply it by something. And so multiplying by 5. If you look at multiplying by 5, that would make the 1 become a 5. It would make minus the 1 height here become a 5 as well. And it would make a 4 become a 20, right? And so way up there at 20, if you checked, it would actually work. Okay, so how that might have worked in your trial and error process, you might have typed in a bunch of things and eventually found that you could type in wait for the keyboard to come up here. Clicking on it, there we go. So the 5x, then shift should work, right? And so you look and you say, okay, there it is. And then we have the luxury and be able to say, okay, let's move this thing down, even shrink it as well. So I can see that 2 and 20 number right there, right? So there's that 2 and 20 that we were talking about. Letting you put a point there right now, but I'll just point with the mouse, right? So there's that 220 spot that we talked about would make sense. I hope you feel that justifies quite nicely for you that the equation we're looking at there is y equals 5x squared. Okay. So similar idea here. That's just the repeat page, actually. That's the blank page that you work from the posted file. So this one here, we're going to look at changing it to be this shape. Okay, so play around. This is the same stuff here where it's the basic equation, the 1, 3, 5 shape, right? And we're going to transform it. By the way you saw this right here is sort of how your graph ends up looking, right? Because you're going to graph the original, then stretch it, right? And I'll just show this one. That I'd kind of like you to think of it as your original was, just go wide enough for here. Your original was almost more like this, right? Where you didn't have all that height and you stretched it up and made the tall blue version. So that height of 4 got stretched up to a height of 20. So it's kind of like that. Right? It's 4 times as, a little over 4 times as tall as it was. Okay, so it's stretched up by a factor of 5. I might have said 4 by accident there. So basically, this this height of 4 got multiplied by 5 to become a 20, and so it's stretching it up vertically. All right. Yeah. So with the next one, notice you're gonna press pause and play around and see if you can get the equation that makes this one, right? For the hint for this one, you want to notice that you have a spot where you have a negative 2 height, right? So a negative 2 height is sort of your key there. So that's going to be a big hint for putting into your equation, right? So give it a try. Come back and see me. All right, so let's do it. We've got this one, may as well get rid of it and say, okay, this time we're going to put in something that makes the upside down and so on, right? So from your previous graphing stuff by hand, hopefully you noticed that a negative number is necessary for the, is that the negative? I hope it is. No, looks like, well, let's see. So eventually you play around with it and you get that, right? And so again, we'll shrink this thing down a bit so we can see what's going on. But yeah, there's the spot. Let me go a bit bigger here too. Show that like it was in the original there. There we go. So this is that spot right here where we have those heights of -2. So I'm just going to take a screenshot of that for the second page where we can sort of show what your product is going to look like. I have the results. I want to focus on it, but when you graph it, really you're graphing this first, right? So this, you graph this first. And so graph it easily as a 0, 1, and 4. It's just off the scale there, unfortunately, when I screen captured it. So when you graph all that stuff first, and then after that you graph the transformed one so you can see the change. And we'll talk about the 2 ways to actually do this when we go through examples. So this is just learning what it is. So this one here, we find it's the -2x squared. And again, the idea of this height here of 1 got multiplied by -2 to give this -2 result down here, right? So I end up with this -2 from having multiplied by -2. So it should make a lot of sense. So again, when we did that, notice that number was there to literally do the multiplication, right? This is multiply in there. So multiply by 2. Yep, that's what we did. Multiply by -2. Same with the previous one. We found that the equation of this one was y equals 5x squared. We talked about multiplying by 5. Well, that's what that is. Multiply by 5. Multiply. Yeah. So moving on here, let's look at the next one, like that one. What makes that happen? Notice this one is the original here, the y squared is the green one. And then it has been, it kind of looks here like it's been stretched out sideways, right? What you really want to think of that as is we were at a height of 1, now we're down at this height. Okay, so we were at height of 1, now we're down at that height. Because these are vertical stretches we're talking about. You can talk about the horizontal stretch version, but it's not worth it, I think, at this stage for quadratics, because you can accomplish all of it just with the vertical stuff, and it's way more direct. The number that you think of from looking at the graph is the same as the number in the equation. So your usual shape, and then you are compressing it vertically, so give that a try in GeoGebra, see what you get. The hint would have been, of course, that these numbers of 0.5 were at as a height. Right? So what happens to make a height of 1 become a height of 0.5? Obviously, we're going to multiply by 0.5. Okay? So let's do that one. Let's go here and just delete that, let's use my regular keyboard here. So I'm just going to type in 0.5 and hit enter, and it gives the picture we're hoping for. Okay, so I will zoom in a little, shot that for us. There, enough. Go. So again, we had our 1, 1 spot, right? Our height of 1 got multiplied by 0.5 to make a resulting height of 0.5. And we have the original equation was y equals x squared. And the transformed version is this y equals 0.5 x squared. So again, our multiplication by 0.5 is happening there. Okay, so everything's matching up, making sense. So summary of this, when we're stretching something, really, we're stretching it vertically, making it taller, but as a result, just notice that it kind of makes it look skinnier if you're graphing the whole thing. Especially if you graph, in this blue example, if you graph all the way up, it kind of just looks like it's skinnier, right? But when you graph it, if you show it the way I showed it here originally, the blue one is shorter than the green one. And in fact, actually, if you stretched really to where it goes to, it would go out to the same width, right? So it'd be something like that. So it would actually be the same width, right? But it's just not how your brain interprets it when you look at it. Same thing for making it shorter. If you squish that thing down and make it shorter, your brain tells you it looks like it's wider, because it is, but what actually made that happen was a vertical compression, so a squish downward. And the number is going to be in front of the x squared, as we discovered with GeoGebra. And so the letter is used as a, right, in the standard form. The ax squared, the a in that version is really your vertical stretch. Okay, so you might have noticed from all the other graphing we've been doing that the a number was to do with that. That was in previous homework practice questions and so on. So if you have a number bigger than 1, you're stretching it, making it taller or skinnier. And if a number is in a decimal, like a fraction, like making it 0.5 the original or 0.2 the original, makes it shorter and therefore wider. And the other thing we noticed from the examples I did is if you have a negative value, then it ends up upside down. Okay? So that's the information that we need to know about. And then the work looks like this, right? So if I ask you to graph y equals 3x squared, then you're going to say, okay, well, I've got my normal, negative 3, negative 2, negative 1, 0, 1, 2, 3. And my normal quadratic, which is 0, 1, 4, 9, 1, 4, 9. Okay, again, this shouldn't be something that takes a lot of calculation time to do, because it's your parent function, they call it, or your parent shape, your starting value, and it's the same every time. You're 0, 0, you're 1, 1, you're minus 1, 1, 2, 4, you're minus 2, 4, and you're 3, 9, and you're minus 3, 9. Okay, so it's supposed to be something where you get familiar with this shape, be able to graph it, somewhere around as fast as what I just did. You're not using a calculator. You shouldn't need to be using a calculator if you're on track. Okay, so this is when y equals x squared. So what I'm going to show you is 2 ways of going about the graph, and you need to be able to do both. But instead of y being x squared, it's going to be 3x squared. So we're going to make a new table, new column in the table. I'll just draw it in my hand, have it ready to go here. But we're going to have a new one where it's y equals 3x squared. Well, the idea on the table is pretty simple. You're just multiplying by 3 to make that happen. Right? So this one's going to be way off the graph at 27. This one's going to be off a little bit at 12. This one's going to be at 3. 0 times 3 is 0. 3, and then the pattern repeats, right? So looking at that, I'm going to graph, those ones at most, right? So that's the the numerical way of doing this, where it's literally just multiplying each of those by 3. Okay, so the 0 stays put. The 1 gets multiplied by 3, becomes 3. The 4 gets multiplied by 3, becomes 12. So I'm going to plot that one just for clarity here. And same thing here. The 1 gets multiplied, becomes a 3. 4 gets multiplied, becomes a 12. Okay, so we get the stretched version of this thing pretty easily just by numbers and by graphing. Okay? You can also, that's kind of the preferred way, really, to do it by table like that. You can also, just multiply or stretch. So stretch or multiply each height by 3. Doesn't really seem a ton different here, though, right? So basically, you'd be saying, well, I'm at a height of 1, and so I'm going to stretch it and make it be 3. So you could picture graphing that without this table of values here, but I really want you to be able to do both anyways. This idea of doing it right from the graph becomes more obvious and useful for some of the other transformations, especially shifts and so on, sideways and ups and down. Okay, so from the graph itself is doable, right? Should be doable. Okay, so that is the first one. So I have to get rid of that one. I'll just erase that one and leave that one blank for you to use on a handout if you want to print it out. Same thing for the next one here. I'll just clone that page, copy of it. All right, so leaving that one for you to use if you want to do this by hand yourself. If we're going to do this one, same deal. -3, -2, -1, 0, 1, 2, 3. Squaring gives you 9, 4, 1, 0, 1, 4, 9. Right, your basic shape that you're starting out with. This is x and y, where y is equal to x squared. So you plot that on. You got your 0, 0, your 1, 1, your 1, 4, or 2, 4, sorry, -2, 4, and 3, 9, -3, 9. Right there. So again, our regular shape all graphed out. So there's your y equals x squared. I didn't label the other one, so I should go back and show like, well, this is your y equals 3x squared. All right, so that, there we go for that. And so for this one, could we do this one right from the graph and get what it looks like? So let's do this from the graph, right? All the y's, all the heights or the y's get multiplied by 0.5. Well, that's pretty easy to do. Your height of 1 is going to become a half. Your height of 4 is going to become 2. Height of 9 is going to become 4.5. Literally just multiplying each of those by a half, right? Half of that one, half of this one, half of that one. So I think I'm showing, and half of 0, by the way, is still 0. So that is the quadratic right from the graph itself. Very easy to do, really, if you think about it. The next, this one here, if you had this and your y equals 0.5x squared, well, that 0.5, of course, we're talking about a multiple of 0.5, right? So times 0.5 gives us those numbers, the 4.5, the 2, the 0.5, the 0, and so on. Okay, so that one is graphed directly from the graph and also by numbers. You can see that it works nicely each way. Get rid of that version of the page from days gone by. And finally here, -2x squared. So let's do our usual here. -3, -2, -1, 0, 1, 2, 3. And you might graph more or less of it. That's usually the most I'm going to see you graphing it. Farthest out, right? If I have a 5x5 grid, you'd only do these ones, right? Anyway, so we get our 9, and our 4, and our 1, and our 0, and our 1, and our 4, and our 9. And we graph it. 0, 1, 1, 2, 4, 3, 9, 1, 1, negative 2, 4, and negative 3, 9. Negative 1, 1, obviously, but over 1 basically to the left is what I was thinking. So there's your y equals x squared. And for this one, let's do this one by the equation here, by the table of values work, and then we'll see that we could do it as well. So this one's your y equals negative 2x squared. So we're multiplying everything by negative 2. That means we're going to get a negative 18, a negative 8, a negative 2, a 0, a negative 2, a negative 8, negative 18. So these ones on the very end we're not paying attention to because they're just off the map. Unfortunately, we're not going to be able to show how stretched this thing is as much as not out to the very edge anyways. We just graph it. So we got our 0, 0. We've got our 1 and negative 2s. So over 1, down 2, both directions. And then we have our over 1, down 8, both directions. You can really start to get quite efficient at this, right? Think of it that way. Right? And so if I wanted to try and shoot out towards that negative 18 stuff, I would just show quite tall, and it helps show that it's stretched upside down rather than looking skinnier upside down necessarily. Right? But again, from the graph, could we have done this? I think so, because we would have just said, oh, well, that height of 1 is going to get multiplied by negative 2, so it's going to end up there. This height of 4 gets multiplied by negative 2, so it ends up there, right? So also works from the graph. So to be able to think about it and do it and understand it both ways is the best scenario. All right, hope that makes sense. Here's your practice questions to do with it. Number 1 is just talking about the transformation. So what would you do? So obviously for the first one, you're going to talk about, you multiply the y's by 8 in the table, or on the graph, take each height and multiply it by 8. So I kind of already talked about the first one there for you. And then part 2, just basically showing what the equation would be based on those descriptions, much like we did, just descriptions instead of pictures, I guess. And then these ones are actual graphs, right? So just like we did in the lesson, I did 3 or 4 to do here. Okay, so that's your practice work for this one. Good luck. Hope that makes sense. Create a help question in the discussion area or email me if you have any questions. I'll make a video for you to help you. All right. Until next time. Till I figure out where to go to turn off this lesson. There we go.